Perfect. Let me just double check that this is set up. Okay. Can you guys see that? Okay, perfect. Great. So I'm really excited to be here today to talk to you about a new open source project that we're starting at Databricks. So, for the first time, I could actually sleep in on the first day of Spark Summit, come a little later in the keynotes, which was great. But don't worry, this is a project that ties very closely to Apache Spark, and I'm really excited to share this with you today. So I think everyone who's done machine learning knows that the machine learning development lifecycle is very complex. There are a lot of issues that come up that you don't have in just a normal software development lifecycle. And to motivate MLFlow, I'll just talk about a few of them. So here's a simple sort of picture of the ML lifecycle. We've got raw data that we begin with, and then we do data preparation, model training, and deployment. And then if we deployed the model, if it's doing something important, we probably want to monitor it as well, see how it's doing, and use that to improve it. So that creates more big data that we then have to process. Now, there are a few different reasons that make this process complex. The first reason is that there are a lot of tools involved. The raw data may come from many different storage systems. The data prep can be done using a variety of tools and libraries as well. Training, there's a huge explosion of machine learning frameworks and algorithms, and same for deployment. There's different places where you deploy. Now, normally in a software development lifecycle, you can just pick one tool for each component. But in machine learning, it's a little bit different because your goal is to get the best result possible for this. So for example, when you're doing model training, you want to try every available algorithm, every framework, and so on. Same when you deploy. You have to deploy the model in many places for it to actually work. So it's important to use all of them. Now, things become more complicated beyond this as well, because some of these steps also support tuning. They have all these tuning parameters that you have to change and explore to get a good model. So this basically adds new dimensions to the whole problem, where now you've got many versions of your lifecycle with different parameters, and you have to understand what happens with the result from each one. On top of that, all of these steps require large scale. Data is sort of the fuel to power machine learning, so you want more of it at every stage. And you also need to pass models and code between many different teams in a typical organization to do these, and that can be a challenge as well. There's no standard way. There's no standard way to do that. And then finally, for any enterprise organization, there's governance and risk management, figuring out what went into each model. Is it following applicable regulations? Can you remove someone's data from it if they ask you about that, and so on. So that's what makes it complex. I'll just show you a couple of quotes from some Databricks customers that use machine learning that motivated our work here. So this here is from the chief scientist at an ad tech company, and he says, I built hundreds of models per day to lift revenue using any available machine learning library, MLlib, PyTorch, R, etc. So in this company, the job of the data science team is very clear cut. They have to lift these metrics like click-through rate and revenue per click, and these directly translate into dollars for the company. And you can imagine, of course, that the data science team wants to use every tool possible. Whenever a new technique comes out, they would love to try it out because every percentage point of lift can result in millions of dollars of revenue. Unfortunately, he goes on to say, there's no easy way to see what data went into a model that I built a week ago, tune it, and rebuild it. So they have to go back and chase and figure out how everything worked. As a second example, this is a large consumer electronics firm, and they have this similar problem at a larger scale. So they say our company has 100 teams using machine learning worldwide, and we can't share work across them. Whenever a new team tries to run some code, it often doesn't even give the same result. And you can see this is also a significant problem. So what can we do to attack these? So companies that have a lot of resources to invest into machine learning have started recently to build custom machine learning platforms. And some examples from the web companies are Facebook's FB Learner, Uber Michelangelo, and Google TFX. So these are platforms that standardize the data prep, training, and deployment loop. As long as you work within the platform, if you build a model using the tools provided there, you can deploy it, you can productionize it, you can monitor it, and so on. And so they save these companies a lot of time. But there are also some limitations to these platforms. First of all, they're often limited to a few algorithms or frameworks. Whatever the ML platform team at your company put in, that's what you get to use. And if you want something else, you're still on your own. And also, they're tied to each company's infrastructure. So, you can't use this unless you're at one of the companies. And people at these companies can't collaborate and share machine learning code between each other as well, or with the open source community. So we started looking at this problem about a year ago, and we asked how can we provide similar benefits to these platforms, but in an open manner. Open not only in the sense of open source, but also in the sense of you can use any tool and algorithm with it and potentially share them across organizations if you want to. And that's why we're introducing MLFlow, which is an open source platform for the complete machine learning lifecycle. So what does MLFlow do? So it has a few interesting features. It works with any ML library and language. It's based primarily on REST APIs and file formats that are very general. And it's designed to run the same way anywhere. For example, you can run MLFlow on your laptop. You can do development. You can also run it in any public cloud. You can use the best hardware, the best features available in every cloud to build your application. It's also designed to be useful anywhere from 1 to 100,000 people, so that one data scientist working alone gets some benefits from it, and the large enterprise using it throughout also gets some benefits. And of course, it's designed to scale to big data and to integrate well with Apache Spark. So MLFlow has 3 main components, and I want to show you a little about each of them today. And this is, I should say, today we're just doing an alpha release of it. So this is just kind of the initial version, and there'll be more components to come in the future. So the 3 components we're releasing today are, first of all, MLFlow tracking. This is an API to record and query experiment runs, so you don't have to ever lose track of what went into getting a specific result or model. And you can use this anywhere to record results. Second one is MLFlow projects. This is a packaging format for reproducible runs, so you can actually run the same code on any platform and get your result back from it or deploy it at scale in the cloud. And then the third component is MLFlow models, which is a general model format that supports diverse deployment tools, and that I'll talk about in a little bit. So to show you more about how MLFlow works, I'm going to show a demo. Let's see how I can get out of this. Okay. Okay. And so for this demo, I'm actually going to use some data sets that we use in the Databricks classes for training. And I'm just going to do a simple machine learning problem, which is we have a data set of Airbnb listings, and we want to predict the price of each listing, the price that people will buy it at based on its attributes. So why might you want to do this? Well, if you're Airbnb, you might want to do this because when someone posts a new listing on the site, you want to suggest the price for them. And you want to tell them, okay, the market rate for an apartment similar to yours is $150 per night or whatever. So very practical problem. It will directly help Airbnb's users. And I'm actually going to do this demo just on my laptop working in this little terminal over here because one of the main goals of MLFlow is it will work the same way everywhere. So I can develop an application on my laptop and then deploy it to a cloud, and it will still work the same way. And what I have here is I have bunch of data files. I've split my data into training and tests, and I have a little start to try solving this problem using linear regression. I'm just using scikit-learn on my machine here, so nothing super fancy. So in particular, I'm using this scikit-learn model called ElasticNet, which is linear regression with regularization, and it has a couple of these tuning parameters, alpha and L1 ratio. And basically, I load my data, I fit the model, and then I run it on the test set, and I print some metrics. And the metrics that I'm printing are 3 common regression metrics: mean absolute error, root mean squared error, and R squared. So I'll talk a little bit about them later. So I've written my code. Now I can run it. I'm just going to run it with Python, and it ran and it gave me some result. I don't know whether these metrics are good or bad yet, but one thing I can tell you is this R² metric is supposed to show what fraction of the variance of the data I can explain using the model, and it's pretty low. It's only 0.24, so I think I can do better. So what I might do next is try to tune this model, and maybe I'll try different values for these parameters. And look, now the R² is 0.27, so that's pretty good. Maybe I'll try this. Nope, that made it worse. Maybe I'll try this. I've actually had a lot of practice tuning this specific model, but in reality, you would probably want to run hundreds of these experiments. And you can see that it gets, it gets pretty time-consuming and challenging to track these things. So this is the first component of MLFlow comes in, which is MLFlow tracking. So this is a simple API that I can use to log my experiments from wherever I run them. It's just a REST API, and then it provides a user interface and API for querying them. And I can share these with my team as well if they point to the same server. So let's try to use MLFlow tracking in this code. So it's actually not many changes. It's designed to be really easy to add to existing code. So I imported MLFlow, and I'm just going to log my parameters. And these are just key value pairs. Oops. Let's log this one too. Sorry, I don't usually type on this keyboard. And then the other thing I had here was I was using print to print the metrics, but let's actually just change them to log metric, and that's it. And then the final feature in MLFlow is you can also log what are called artifacts, which are just any arbitrary files. Could be the model you produced, could be an image, for example, of your model's performance. And I'm just going to log a plot that I happen to have in this folder to see what that looks like. But I could have maybe generated this plot. So that's what I did. So now if I run this again, it will run much as before. MLFlow still prints the metrics when I log them, so that's kind of convenient. I'll just run a couple of these. But now what I can do is I can use MLFlow to visualize my history. So what this actually did is it logged it logged all these results into this folder on my laptop by default. You can also log to a server if you want. And I can just launch a UI to view what my experiment was doing. And then I can go here and actually see that UI. And in the UI, you can see these are the runs I did, and it's suddenly much easier to keep track of the metrics and see what we're doing. You can see I lifted up the R² up to 0.28 almost here, and I've got these parameters. MLFlow logs some additional information as well. For example, I have the git commit. My project happens to be in a git repo, so I can see exactly which code I was running. And if I click here for each run, I can also see the artifacts that I logged. So I logged this plot.png. I can just view it in here and go back and see what I was doing. And of course, if you don't want to work with the UI, you can download this data or use a REST API to query it and work with it in your favorite tool to look at what happened across hundreds of experiments. So that's the tracking API of MLFlow. So now we can keep track of what we're doing. But we're not really done with this machine learning problem. We got the R² up to 0.27. That's OK, but it's not amazing. So next step I'm going to try to do is use some different algorithms. And usually data scientists today would just start looking for these online to find some examples. So let's say that I want to do decision trees, and I want to use XGBoost. And I'll look for how to do regression using XGBoost. There's a bunch of docs. If I'm really lucky, I might find a GitHub repo that does it. But now I'm kind of stuck. So in this GitHub repo, we've got some code, but I don't really know what's required to run it. I don't know what data format it's in, how to modify it to handle that. And I also don't know what dependencies it has to install it. If I just set this up, what Python dependencies, what libraries, what cuDNN version, that type of stuff do I need. So it's very hard to just take a Git repo and run it. This is where the second component of MLFlow comes in, which is MLFlow projects. So MLFlow projects offer a standard way to specify your project where you can specify the code, but also configuration and data files related to it. So you can run it the same way either locally or in the cloud. And luckily for XGBoost regression, one of the data scientists at Databricks actually has built XGBoost regression project using MLFlow. So now this here looks very similar to the other one. It's a Python repo, it's a Git repo with some code, but there's description file in here called ML project. Let me just zoom in on that a bit. And what you can see is this is a little text file that describes the dependencies. So this is a Python conda environment, and also the code I can call in the project. So there's a thing called an entry point called main, and all the parameters of it. And then in here it says how to pass these parameters to this thing. So as a user of MLFlow, I can use this project without understanding the internals of the code, without even knowing that it's written in Python. Actually, it could be written in something else. One of the cool things about this feature is you can run projects from a GitHub URL or just from a Git repo URL. So what I can do here is I can do MLFlow run and put in this URL and then just pass in my parameters. Oops. And then I need to tell it which column to predict. So I want to predict the price. And I can just start this off. And what MLFlow will do is it will download it from Git. It will actually set up a conda environment that's specified in that repo. And it will then run it. And you can see we just ran this XGBoost code. And for our machine learning problem, it's actually looking pretty promising because now we've lifted the R-squared to 0.281, which is way better than we had before. And of course, I can take this project and tweak some of the parameters too and tune it further. So I saw decision trees were good. Let's try adding more trees. And I'm just going to bump up the number of trees to 400 and see how that does. And again, it will run it. And now our R-squared is up to 0.43, which is great. And we could try adding even more trees, actually, and see what happens. It's going to take some time. And this one, it actually doesn't seem to increase it much further. So all these things that I ran, so I was able to just run it from a Git URL. All these things that I ran were, of course, logged here to my server. I'm actually going to just hide some of the data parameters just to make it easier to see. So you can see, OK, this was this run. And what you can see with this, because it's running from a project, we actually have a link, because it's on GitHub, we actually have a link to the specific Git commit that I ran. So MLFlow remembers that. And if I click one of these runs, I can even see the command to reproduce the exact same run with all the parameters with that same version of the code. So that's pretty cool. So now I can just run this and send my project to someone else, and they can do the same thing. And then finally, you don't have to just run the projects locally. I can also run any GitHub, any MLFlow project on Databricks and on the public cloud that way. And I can just pass a cluster.json, which is a spec for my cluster, and I can point it to, I should point it to data that's actually on there. So I'll point to data that's on there, and then I can just kick it off. So this will actually kick off the job on Databricks, again, with the same parameters. And if I want, I can actually view this job and see that it's actually running over there. So there it is. So I'm not going to wait for this to finish, but I just kicked off my same job in the cloud. You can run it on more data or run lots of experiments in parallel that way. OK, so now the final thing we want to do is we've got some pretty reasonable predictions now, and maybe we want to deploy a model. And this is where the last component of MLFlow comes in, which is MLFlow models. So these are a model format, but they're a little bit different from, say, model formats like Onyx and PMML, because you can save the model in multiple flavors, including very simple to run flavors like just a Python Lambda function. And then you can deploy these to different platforms. So for instance, anything that you save as a Python function in MLFlow, you can put it in a Docker container, you can run it on Apache Spark, or you can run it on SageMaker and Azure ML as cloud-hosted serving platforms. So the code that I ran in this project actually already is set up to log a model. And you can see a model is just an artifact. It's a folder. And it's got this description file. And it's also got a binary data file. And in the description file, I'm just going to zoom in on this a bit, you can see this particular model has 2 flavors. So you can view this model as a Python function, just load it using this module. And you can also view it as a scikit-learn model. So if you want to use scikit-learn, you can load it back as a pipeline component and tune it and so on. And it also remembered the run ID and when I created it. So I can just take the run ID, and MLFlow provides a variety of built-in tools that can work with these models. So just as an example, I'm going to run this. This is a tool to just apply the model locally to a CSV file. And I just pass it on this input file I have with a few records. So you can see I just ran it on there and predicted some stuff. And then I can also look at in prices, which is the actual prices for these things. And I can see, my models actually is definitely matching the trend of these, though it is over predicting at least the price of some of these properties. So it's definitely learning something. It can be improved. And then the other thing I'll show that you can do with it is export it to different tools. So one of the tools I can export to is Azure ML Serving. And here I can give it a folder to deploy to. And then if I look in here, this is actually a self-contained Azure ML project that I can deploy as a service on Azure ML to serve. And I don't have time to actually deploy it here, but if I want, I can call one that I had before and pass it in JSON file and actually have it run over there. OK, so that's a quick tour of the components. So that's MLFlow. We're releasing it as alpha today. There's a bunch of integrations with some popular libraries, and there's Python and REST APIs. And we just started this project, so there's a lot more to come. And we would love to see your feedback and see what your experience is like running it locally and in your team. And of course, at Databricks, we are also offering hosted MLFlow on Databricks. So this is integrated with Databricks jobs, notebooks, security, and Delta. You can easily run at scale and tie in with everything in the rest of the platform with the whole security model and resource management and so on. And we're opening up signups for a private preview of that. So we'll have a list to get that started. So if you want to find out more about MLFlow, come by our booth and talk to our team there. Thanks.